Hey, this is Math 0965. Today we're going to look at 6.1, the greatest common factor and factoring by grouping. So the way this is going to work is kind of reversing the process of distribution. So first section, factoring out the greatest common factor. So recall doing a distribution, recall distribution. So basically, for example, maybe you have something like 3x to the fifth times 2x plus 1. Okay? So how did distribution work? Basically, you're multiplying twice, right? So you get 3x to the fifth times 2x. So you multiply 3 times 2 is 6. And then x to the fifth times x is x to the 6, right? You add the exponents. You kind of pretend there's a 1 there. So 5 plus 1 is 6. And then 3x to the fifth times 1 will just give me plus 3x to the fifth. Okay, what we want to do is reverse this process. So we want to reverse distribution. And there's a couple ways you could do this. For example, if you were just given 6x to the 6th plus 3x to the 5th, you could just factor out part of it, right? You could just factor out the 3, or reverse distribute the 3. And you would have 2x to the 6th plus x to the 5th, right? And if you redistributed 3 times 2x to the 6th, you would get back 6x to the 6th. 3 times x to the 5th would give you back 3x to the 5th, right? But you could also factor out 3x. So 6x to the 6th plus 3x to the 5th. You can factor out the 3x, right? And so in this case, you would have 2x to the 5th plus x to the 4th. So what I'm getting at, and maybe you don't understand how I'm doing this kind of process of reverse distribution just yet. What I'm getting at is that there's more than one way to do this reverse process. Okay. Going forward, it's kind of like set in stone, but going backwards, it's not quite, well defined. Different people can get different answers, right? So what we do is, in particular, factor out what's called the greatest common factor, and that way we all do it the same way, and there's no guessing involved. Okay? So what would be the greatest common factor then? The 3x to the 5th, right? So if you're given 6x to the 6th plus 3x to the 5th, the biggest thing that I'll divide both of them, the biggest term, so what I mean by that is the biggest thing that has number in it and a constant and a variable. The biggest thing that you can factor out both, what divides both 6 and 3? Well, 3. And then what's the biggest variable part that will divide x to the 5th and x to the 6th? That'll be x to the 5th. Okay. So reversing the distribution, we'll get 2x plus 1. Okay, so that's kind of where we're headed with all of this. It's kind of a foreshadowing. We're going to teach you how to identify the GCF, and then we'll work with this process of reversing distribution. Okay, so the first thing we want to be able to do is just identify the GCF, the greatest common factor. So finding the, I'll just say GCF, okay? Okay. So the first couple problems in your homework, they're going to give you two terms. So for example, 12x squared and 8x. And they want you just to identify the GCF. There's more than one way to kind of skin the cat here. You can completely factor both of these. And this is usually the hard way, the long way. So 12, if you think about, and you may have to do a number tree when the numbers get harder and harder, but 12 is the same as 2 times 6 over here to the right. 6 is the same as 2 times 3, so 12 is 2 times 2 times 3. And then x squared, that's just x by itself 2 times, x multiplied by itself twice. Right? So it's just x times x. And then 8x, let's see, 8 is 2 times 4. And then 4 is 2 times 2. So we have 2 times 2 times 2 times x. Okay? And then the GCF is just the common parts. So each of these terms has a common factor of two twos. I say 2 twos, but the same as 4, right? And then they both have an x. Okay, and then that part is your GCF, the 2 times 2 times x, okay? Which you should write as 4x. So that's one way to think of it. Another way is just kind of the brute force method, to kind of look at these two numbers and say, okay, what's the biggest number that divides both 8 and 12? You say to yourself, well, 2 divides both of them, but is that really the biggest number? Like 2 will go into 8 4 times, 2 goes into 12 6 times. And no, it's not. You could do better than that. 4 is a bigger number that divides both of them. Okay. And then for the variable part, you kind of have to to maximize the number that divides both of them, you're looking for the smallest. So you're actually looking for the smallest exponent. If you think of the exponent on x is 1, then the biggest thing that will divide both of them will just be x to the 1. Okay? So it's another way of kind of thinking through it. But okay. Hold on. Hello? Sorry about that. More spam. I want to thank all the robocallers for calling me perpetually throughout the day. All right, sorry about that. Anyways, moving on. Let's look at another one. This time we'll look at 3 terms, okay? Because it's not always going to be just about, 2-term scenarios where you're trying to factor out one. You have 2 terms, you're trying to factor some stuff out. You can have 3, 4, 5 terms. Okay, so this next one, 9y to the 5th, 18y squared, and negative 3y. One thing about the GCF is we're always going to assume it's positive, so don't worry about the negatives with the GCF. Anyways, let's kind of think this through. All right. So what's the biggest number that divides 3, 18, and 9? Well, I think the biggest number will be 3, right? And you got to make sure, 3 divided by 9, yeah, that works. Just 3 go on the 18, yeah. So I think the biggest number will be 3. And then for the variable part, you're always just kind of looking for the lowest exponent, and that's going to be on the y, this third term, the negative 3y. It's exponent. If you don't see an exponent, it's just 1, right? So it's going to be, this will be your sort of greatest common variable, okay? Okay, so I'm predicting my GCF should be 3y, just kind of feeling it out, I guess. Let's make sure though, and brute forcing out the factorization here. So 9 is the same as 3 times 3, and then y the 5th, y times y, there's 5 of them, right? 18 is the same as 2 times 9, and 9 is 3 times 3, so you get 2 times 3 times. If you need a number tree, do that. And then y squared, that's just y times y. And then finally, negative 3y, you could write that as negative 1 times 3 to kind of factor out the negative part. And then you'll have a y. So circling kind of the common parts, there's a common 3 to all of them. So there's my 3. And then each one has a factor of y. Okay. So 3y. Okay. Let's look at one where we have multiple variables involved. So xy squared, xy cubed. Okay, so it's kind of counterintuitive with the GCF when it comes to variables. It's like, With the constants, you want to find the biggest number that divides all three of the terms, but it's really not the biggest number, right? If you look in this example, you're not looking at it's the common factor isn't 18, right? You're not putting 18 here. It's kind of the biggest, the smallest, or something like that. You know, the biggest number that will go into all three. Right? So when you look at the variables, you're not going to put something like, I mean, you'll put x, but you're not going to put y cubed, right? You're just going to put the smallest exponent right there, the y. And again, let's rewrite that as just xy. You don't need to put the dot in between. We assume that xy and x times y with a little dot are the same. But if you do the factorization, you can see, you know, the common parts. Y times y, x times y times y times y. So we have one factor of x and then one factor of y. Okay, let's look at a real hard one now, where we have a mixture, constants, and then multiple variables. So we have 18x to the 5th, y to the 4th, 6x to the 6th, y cubed, 12x to the 4th, y to the 5th. Okay. All right. And we're looking again for the GCF. So, what's the biggest number that will divide all three of these? Okay. And the biggest number turns out to kind of be the smallest number amongst these three numbers, 6, right? 2 will divide all three of them, but you can do better in 2. 6 will divide all three, so we have 6. And then for the variables, again, for the x variable, you're just looking for the smallest exponent. So x to the 4th will go onto all of those. And then, again, for the y cubed, right? And if you want to brute force kind of do the factorization, so 18 is 2 times 9, 9 is 3 times 3. And then, and now you're kind of saying, oh, I don't like this method because I have to do a lot of work, right? But, you know, sometimes you kind of have to do it, you know. It's just this method is probably not going to be a good long-term method, because you'll have too much other stuff to worry about. 12 is 2 times 6, right? And then x to the 4th, and then y to the 5th. And then we're looking for the things that are common. So all of them have a 2 times 3 part. And then all of them have 4 x's, at least. And then all of them have at least 3 y's. And there, you see our GCF. So 6, x to the 4, y cubed. Okay, so now let's go ahead and move on then to this, what we're after, factoring out the greatest common factor. In other words, this reverse distribution. Okay. So factoring out the GCF. Okay. 8x plus 8. So what you're doing is kind of identifying the GCF between these two terms. Okay, so if you had, just like above, 8x and you have 8, the GCF, the biggest number that divides both of them would be 8, and then there's no variable part that divides both of them. So the GCF is 8. Okay? We want to factor 8 out of both these terms. So the way they're going to do it in the book is to rewrite 8x as 8 times x, and then rewrite 8 as 8 times 1. Okay? And then when we do our reverse distribution, what we're basically doing is kind of pulling this 8 out. Okay? We're going to pull that 8 out and kind of put it out in front. So you'll have an 8 here, and then the leftover bits will just be the x and the 1. So you'll have x plus 1. And you can always check your work. So you're always going to know that this is, you know, the correct version if you just kind of redistribute in your head, right? So you could say to yourself over here in La La Land, 8 times x plus 1. Is this going to be the correct factorization? Well, 8 times x is 8x. 8 times 1 is 8. And is that what we started with? And if you look over here now to the left, yeah, that's what we started with, so it should be correct. Unless you factored out something that wasn't the greatest, unless you just factored out 2, you could do that, and it'd still be kind of technically right, but we need the GCF. Let's just keep on turning out a bunch of these examples. Okay, 4y minus 4. So again, in your brain, you're thinking of the GCF of 4y and negative 4, if you wish. The GCF, the biggest number that will divide 4 and 4, will just be 4, and we don't use the negative with the GCFs. So what we're going to do, what the book does, is rewrite 4y as 4 times y, and then rewrite negative 4 as negative 4 times 1. And then we're going to factor out this 4 part. Okay. Go down one line here. And I'll have a 4 out in front, and then the leftover bits are the y, and then the minus 1. Okay. And again, in your brain, you could redistribute. 4 times y is 4y. 4 times negative 1 is negative 4. So it seems to work. Let's try this. X squared plus 5x. Okay, so what's the GCF this time? Looks like it's just x, right? So x squared is just x times x. 5x is just 5 times x. The common parts are the x's, so the GCF is x. Okay, so I could rewrite x squared as x times x, just factor it, and then 5x is the same as 5 times x. And then you could pull out the x I should have wrote 5 times x as x times 5. So it looks a little more like, you never really write it that way though, right? Anyways, I'm going to factor out the x from both of them, put that on front. And then what am I left with? X plus 5. And you could redistribute if you need to. Here's another example. I have 14x cubed plus 21x squared. Getting a little harder now. Okay, so the GCF, the biggest number that will divide 14 and 21, I think that's 7, right? So sometimes I'm guessing. I don't know exactly. And usually, even if I get it wrong, I can kind of go back and fix it. Okay, the biggest variable that will divide x squared and x cubed will just be x squared. Okay. So you can factor both of these into 7x squared times 2x plus 7x squared times 3. And then you're pulling out the 7x squared, and you're left with 2x plus 3. Usually, once I get rolling, once you get better and better at this, you can kind of skip this step, right? At first, it's not a bad idea to kind of play around with that. I give you a little practice. But ultimately, the way I'll do it is kind of like in this next example. Okay? So this next example, let's take a look. 9y to the 4th plus 27y to the 6th. Okay? So what I'm going to do is figure out the GCF and just kind of put it right here. And then, I'll have times this, whatever. So what is the GCF this time? What divides both 9? What's the biggest number that divides 9 and 27? Well, it's just 9. And then the biggest variable that goes into y to the 4th and y to the 6th. Well, that'll be the one with the lower exponent, y to the 4th. Okay, and so what is kind of left over then? What times 9y to the 4th gives me 9y to the 4th? And it's just 1. And then what times 9y to the 4th gives me 27y to the 6th? You could say that's 3 times 9 give you the 27. And then y to the 4th times y squared will give you y to the 6th. So in practice, I don't really do that extra step. I mean, you can do that, but I think it's a little more direct just to kind of go straight to the answer that we're after. And you'll get there eventually. Even if you're not there yet, it just takes some practice, and after a while you kind of get a flavor for it. You kind of get a taste for it, rather. Let's look at a harder one. 100 y to the 5th minus 50 y cubed plus 100 y squared. Okay, so the GCF, the biggest number that divides 50, 100, and 100 is 50. The biggest variable that goes into all three of these will be y squared. Okay, and then there's three parts in there. So 50 y squared, what times 50 gives you 100? Well, 2. And then y squared times what gives you y to the 5th? So I'm trying to kind of recreate this, right? So that's going to be y cubed. And then minus, I need to kind of imagine that part. So 50y squared times what gives me 50y cubed? Well, y. Give me 50y cubed. And then plus 2, and then just 2. 2 times 1, basically, so just 2. And that would be it. And you shouldn't have that big space there at the end. I'm going to get rid of that so it looks a little prettier. Okay, two more. So this one here is a curveball, 11x squared minus 23. And you'll see this sometimes in the homework. It doesn't come up very much. They'll ask you to factor it, but usually they give you an extra option. Like if you cannot factor this, then just write, whatever. I think it's NCD, or usually I used to write NCD. We'll look at Mymathlab here in a bit. But nothing goes into both of these. Okay, so there's no way to do it. You cannot factor. Excuse me. Cannot factor that binomial. Okay. Let's do one more that has constants and then multiple variables in it. So we have 30x squared y cubed minus 10xy squared plus 20xy. Okay, so what divides 30, 10, and 20? Well, 10. And then the smallest exponent for x is just x. Smallest exponent for y, that will just be the y to the 1. And then we have sort of the leftover bits. Okay. The first term will have to be 3x and then y squared. And then the second term will be just y. So 10x times y gives me 10x y squared. And then the third guy will be plus 2. And that would be it. Okay, so let's worry about something new now. Okay, let's move on. Factoring out a negative coefficient in the first term. Every problem we've done to this point, what we've been factoring out is the GCF, the greatest common factor. And the greatest common factor, as I noted above here, does not include the negative, right? So, and these first kind of problems, even if we did have a negative, like in this example here, we did not include that in the GCF. Right? But now we want to pull out a negative for whatever reason you may have. So let's take a look at how this is going to work. Okay, so let's say I have negative 15x squared plus 20. Okay, it's kind of business as usual. I'm gonna factor out the GCF. So the number that goes into both of these will be 5. There's no variable that will divide into both evenly. And then I'm just gonna tack on a negative, okay? And what the negative will do is kind of flip the signs of the two terms. So the first term, instead of being negative, will now be positive, and the leftover parts will be 3x squared. So negative 5 times 3x squared is negative 15x squared. And then the next term, instead of being plus something, will be now minus something. So what times 5 is 20, 4. Right? And you could redistribute in your brain and kind of see the truth of this. Negative 5 times 3x squared minus 4. So negative 5 times 3x squared is negative 15x squared. Negative 5 times negative 4 is plus 20. And that's where we started, right? That's this thing. Let's get another one. We have negative 8x to the 4th plus 32x cubed plus 16x squared. Okay. So we're pulling out a negative. What's the GCF? Looks like 8 will go into all 3 of the constant parts. And then the variable with the lowest exponent, x squared. And then what's left over? So for noting that I have to change the sign. So it's going to go, instead of minus plus plus, it'll go plus minus minus. Okay, so the first term will be x squared. Negative 8x squared times x squared will be negative 8x to the 4th. The second term will be 4x. Okay? And then the third term will be 2. Yep, that'll be it. Okay. The sort of last topic, and then we'll look at an application, and then go look at WebAssign, is factoring by grouping. And this may be different. When I was in school, they didn't teach this method. Okay, so if you're as old as me, which would be as old as dirt at this point, you may have not seen this before. But I think most people now in the school, they teach this. But here we go. Factoring by grouping. And instead of just factoring out one single term, we're going to factor out a common binomial. Okay, so 2 terms, basically. It's a little weird. So factor out the common binomial. Okay. So let's look at some examples. And the first parts, they're kind of already done for you a little bit. So okay, let's just look at it. X times x plus 5 plus 3 times x plus 5. If you think of this as just 2 terms, okay, so here's the first term and here's the second term, each term has a factor of x plus 5. Okay, so that's common to both of them. There's an x plus 5 here and an x plus 5 here. You could factor that out. Okay, you could say, all right, let's take an x plus 5 out of both of those. And then what's your leftover bits? Well, that would just be the x and the 3. So x plus 3, you just put that in parentheses. And that's it. Very cool. Let's do a couple more. So I have x times y plus 6 minus 7 times y plus 6. Okay, pretty easy, right? You're just going to factor out the y plus 6. So we have y plus 6 times, in the leftover parts, x minus 7. And there is a multiplication in between these two binomials. We don't write it, but it's in there. Okay, so I've seen people try to put a plus sign in there. No, it's not a plus. It's these two guys are multiplied. It's just kind of, I'm getting a little crazy with my parentheses. I need to tighten that up a little. Okay. Let's look at another 4x times, and I get all these examples from the book, so I'm not like making these up. Okay, maybe this one isn't as clear, but you could kind of group or associate terms together, right? So you consider 4x times 3x plus 1 as one term, and 3x plus 1 as another term. You could put parentheses around them like this. And then you could rewrite this as like 4x times 3x plus 1 times 3x plus 1. And you see, all right, these two guys have a common factor of 3x plus 1. So I could factor that out of both terms, put that in front. And then the leftover parts, the 4x plus 1. And that's it. Okay, so these first problems are a little easier because they're kind of already set up for you. And in the real world, they're not going to be like that, right? They're going to be kind of in their natural habitat, they'll look more like this example. So x squared plus 3x plus 5x plus 15. And the way you can kind of identify these is there's 4 things there, first off. And you could look, if you look 2 at a time, like if I were to group these 2 together, like associate these 2 and associate these 2, you could factor out GCFs from those 2 pairs, right? In the first pair, I can factor out an x, and I'll have x plus 3 left over. And the second pair, you can factor out 5. If you do that kind of factorization and you see a common binomial, then you can factor out the common binomial. So in this case, we could factor out an x plus 3. And then you're left with x plus 5, right? Let's get 2 more of those. And I should note, I'll probably mention it in our lectures and stuff, but you could always speed up my videos. You could slow down the videos, because it's in YouTube. They have that little button that will speed it up, slow it down. You can pause the videos. When I was a student in class, what I would usually do is see if I can, once I got good enough, I would see if I could do the problems before the teacher would do the problems. Because the teacher has a lot on their plate, right? They're trying to make sure everybody understands it. They're trying to do it in different methods so people with different learning styles can understand it. They're talking at the same time they're working. So usually as a student, you could do it faster. You could do this problem before I do it, especially if you're following my program. You're reading the book. And then you're coming here and listening to my lectures, right? And you're going to class and you're doing the whole 9 yards. You should be able to kind of predict where I'm going and kind of do the problems on your own. So hopefully you're doing that. We're going to make this problem here. This problem will be the video quiz. Okay? So for the video quizzes, you're writing them down on a piece of paper. You're going to collect like 1 video quiz per lecture, and then you'll turn them in the next week. So this week is 6-1, 6-2, 6-3, 6-4. There'll be 1 little video quiz question in each video. You'll put them all 4 video quiz questions on 1 piece of paper. Then you just scan it. You could take pictures with your cell phone and then paste those pictures into a Word document. And then when you go and save your Word document, you can save it as a PDF. I can show you how to do that really quick. So usually I like the snipping tool right here. Let me do the question first, and then I'll show you how to kind of put it into a document. Okay, so I'm gonna group these 2 at a time. So here x factor out at x plus 7, and the second 2 terms I'm going to have to factor out a negative. Otherwise, I'd end up with negative x minus 7, which wouldn't give me a common binomial. But if you factor out a negative 4, you're going to end up with x plus 7. Okay? And then you see, oh, I got a common factor of x plus 7. Okay? So you can factor out the x plus 7, and then the leftover part, x minus 4. Okay? So that would be our video quiz for this part. And for me, because I'm using this kind of notes on my computer, I'm going to go to this great snipping tool I love. And I just kind of take a picture here. So file, save as, and then I can go video quiz number 1, 0965, save. And then I'm going to go to Word. And what you would have to do is probably take a picture with your cell phone and then upload it to your computer, and then go to Microsoft Word, and then insert that picture into the document. Okay, so let me go find where I stored this thing. So there's a lot of work over the summer. You take these summer classes, a lot of work. Okay, so I put it into my document, make sure your name is on it, and your section and all that good stuff. And then you're going to save it. but when you do save it, you save as. And then it says save as type. Hit that thing and go down to PDF. Okay. So this is video homework 1. And I'll put that in the same place I put it before. 65. And I'll save as a PDF. And then usually it has to think about it, and it'll put it in a PDF form for me. And then you can send it to me. The reason I need everybody to send a PDF form is because if everybody sends me pictures, it'll kill my mailbox. Okay. Okay, so you need the PDF form, and when we take our tests, it'll be like that too. We won't be taking our tests online. It'll be through WebEx, and I'll have you download the test and then write it out, and then you're going to have to take pictures and upload it, convert it to PDF, and then send it to my email. Okay. But anyways, that was our first video quiz. You just write it out like I have it. Please show all the details, and you'll get 1 point for each video quiz question. So let me write in my notes that problem. So new. So this is 6.1. Okay. Let's look at the application. And there's a similar application in Mymathlab. So I think we're going to go look there at the applications. That's usually a good idea. Okay, so let's go into Mymathlab. You would go to your Assignments tab once you get your Mymathlab set up. You can see all the assignments are due for Chapter 6 on the day of the Chapter 6 test, which is 6/10, June 10th, so not very far away. These classes in the summer are very quick. So let's click on this. Look at maybe some of the. Sure, let's look at some of these questions first. This is a hard one. So you're going to get a lot of practice. There's a lot of homework, probably about 30, 40 questions in every section. Each section is worth 4 points possible. Okay, so let's try this problem. And there's always this option, the polynomial can't be factored. This is not an application. Factor. They want you to using the negative of, so they want you to factor out the negative. Okay. Of course, now I can't read it. So negative 16a cubed b squared plus 12ab. Don't be intimidated by all the numbers and variables. They tell me using the negative, okay, of the grade. So you're going to factor out a negative. What divides 16 and 12? The biggest number there, I believe, is 4. And then for a cubed and a, that'll just be an a. And b squared and b, we need a b. So then the leftover parts we'll have, and then we change the signs. So the first one will be positive, and the second will be negative. 4 times what is 16? Well, 4. And then we need an a squared, and then an extra b. And then what times 4 is 12? So the 3, right? And then we don't need the a and b. Okay, and then we just type it in here. You could use the caret key for exponents. You don't need to go down here and click on that. You can just use the caret key. So anyways, negative 4ab times 4a, and then I hit caret, and it gives me an exponent. So I don't have to. I can just do the typing, and then you have to arrow out of the exponent, and then minus 3, end parentheses, and check your answer. Yay! Okay, here's an even harder one. Okay, let's fast forward to the applications. Okay, so first application. The figure shows a circle drawn inside a square. Write a polynomial that represents the shaded area in the figure. So the way you could kind of figure out the shaded region is by finding the area of the box and then subtracting away the area of that circle. And then that will give you the area of the shaded region around it. Okay, so the area of the box, if this length is 8x, and then this length is 8x, That area of a box, side times side from geometry, we have 8x times 8x. And then minus the area of the circle. So what's the area of the circle? Pi r squared. The radius here is 4x. So pi times r, which is 4x squared. Okay. So it's the difference between those two things. Let's rewrite that. 8x times 8x is 64x squared minus 4x squared. How do I figure that out? You can kind of think of it as a distribution of this exponent, so it'd be 4 squared x squared. Or you could think of it as 4x times 4x. Lots of ways to think of it. Anyways, you'll end up with 16x squared, and then there's a pi in there. We usually put the pi after the constant, but before the variables, I believe. 16 pi x squared. Okay? Looks a little weird, right? What do they want? Write the polynomial, simplify your answer, do not factor. So usually we would factor out something, but okay. So x caret squared minus 16. Usually if you just type pi, it'll turn into a pi like that. And then x caret squared. Okay. Well, and then they want us to factor it. Okay, so it looks like we can factor out a 16 from both terms. 16 goes into 64 and 16, and then we can factor out a variable x squared. Okay, so we'll end up with looks like 4 minus pi. Okay, let's see if that's right. 16x caret squared times 4 minus pi, and parentheses, check answer, yay. Projectile motion, math is everywhere, okay, it really is. Some people claim, and this is a crazy thing, that the universe is made of math, okay, and our specific kind of being, what we are and how we act and what we do, is all determined by kind of the mathematical structure around us. And there's different universes with different mathematical structures, believe it or not. And they call it like the multi-universe idea. If you ever watch like Rick and Morty, they always talk about the multiverse. At least I think they do. Anyways, if you look around you, especially if you are into baseball or something like that, you'll note that when balls fly through the air, when baseballs are hit, they follow a kind of particular type of path, right? They don't go straight up and then straight down. Well, sometimes they do, but usually they follow a path that math people will call a parabola, okay? So if you have like a baseball person there, generally when they hit the ball is going to kind of go like this, okay? It has that distinctive style. It's kind of boring to us because we've seen it before, but I mean, imagine it has other possibilities for traveling, right? It could go like this, and then like this, and then like this, and the ball could do that, literally. But it doesn't. It chooses to do this first, you know. The ball is choosing this. So the shape becomes very, very important. The shape can be described via these objects, these polynomials that they call quadratics. Okay? And in this question, where we can use this quadratic to describe the ball. Okay? So a ball is thrown straight upwards in this case, and the polynomial 80x minus 16x squared describes the height of the ball above the ground. So let's give this kind of a name, h, right? And feet, x seconds after it is thrown. Right? So h, this is the height of ball, and x is the number of seconds after it's thrown. So I like to write stuff down. It kind of helps me as I read math. Recording as a math is not the same as reading like a book, right? You literally, whenever I do math, I need to have a piece of paper and a pencil right next to me. It's just the way it is. And it's not as quick as reading a book, okay? Anyways, find the height of the ball after 3 seconds. So to figure that out, what you're going to do is take the number 3 and plug that in for x. Okay, so the way we kind of write it, we'll write it eventually, will be h of 3. And we plug 3 in for x. Okay, so we have 3 in here minus 16 times 3 squared. And then it turns into, please excuse my dear Aunt Sally. So 80 times 3 is 240 minus, you have to do exponents, so 16 times 9. Let's get my calculator out. Calculator. So 16 times 9, 144. So 240 minus 144 is 96. And get some units. So it's just height. It's not telling me. Oh, it's feet. Okay, so the height of the ball is 96 feet. 96. Okay. Oh, they want you to factor the thing. So just put B. I'm going to go back and factor this guy. Where are you? Of course, it's going to go right off screen, so I can't read it, right? All right. Looks like I could pull out an 8 out of both terms. Can I pull out anything else? Maybe a 16. Whoa. 16, I could pull out an x. So that is, it's 5, right? It's 5 times 16 is 80. And then minus x. 16x times 5 minus x. Use the factor form to find the height after 3 seconds. Okay, so I'm just going to plug 3 now into this formula. You get the same answer if you use the other formula here. It doesn't really matter. Sometimes a little easier to use this other form because it'll make the computations quicker for us humans, right? So this will be 16 times 3 times 5 minus 3. 16 times 3, see, I can do that in my head. It's 48, and then 5 minus 3 is 2, and then I'll be 96. So I didn't need my calculator. So I guess they're trying to teach you the moral of that parable, you know, is that you can kind of do it a little quicker if you just do this extra bit of work. Okay. Did you get the same answer? Yeah. Okay, I get it. Yeah, thank you. So does this prove, well, does this prove that the factorization is correct? I would say no. It's still possible that you screwed it up, but you just got lucky. Okay. So proofs are a weird thing in math. You want to say, so it's kind of, the example I always tell my students is if you drove 100 miles per hour into work and you got away with it once, would you always get away with it? And no. Okay, you're going to have to go, and you learn proof methods. If you kept taking math, you would learn how to prove this kind of stuff. And so you always have to be careful not to make too big of an assumption. You know, you make an assumption, you make a ass out of you and me, right? So, yeah, be very, very careful. I want you to kind of guess, though, sometimes. That's not a bad idea, and play around with stuff. But yeah, you just have to be a little can about your conclusions if you've not taken these like advanced proof classes, okay? But that's, you know, you still can make guesses and assumptions. Just don't build any bridges based off of those. Let's see what this guy is. Write an expression for the length of the rectangle. Oh, you just multiply the 2. Oh, I see. So this one's kind of weird. So they give you the area, and they want you to figure out the length of the rectangle. So the area of this thing is 3x to the 5th minus 15x squared. And then they tell you this is 3x squared, and they want you to figure out what is this length. Okay, so how the heck would I do that? Well, you know it's going to be length times width equals area, right? So the 3x squared times this unknown part which I just put in parentheses, equals the 3x to the 5th minus 15x squared. And once you put it up, set it up like that, it's kind of like a distribution, right? It's just we're kind of doing it in the reverse order. So you say 3x squared times what gives me 3x to the 5th? Well, x cubed. And then minus 3x squared times what gives me negative 15x squared? Well, I think that's just 5. Right, so x cubed minus 5 would be your answer. I hope. Did I miss something, didn't I? Oh, doesn't look like it. My cat needs me. So we'll leave you with that. A lot of homework in there. Get started, get it all out of the way. You know, the summer class is brutal for that reason. So tons and tons of homework. The more homework you do, the better you're going to be, though. So thanks for watching. Make sure you did the video quiz. You found the video quiz this time, and we'll see you in the next video.